Welcome to Curie Electronics. In this video, we are going to learn about working and various blocks of cathode ray oscilloscope, or simply we'll say CRO. So this is the cathode ray oscilloscope, this is based on CRT, and this is the latest or newest generation of oscilloscopes. These are called digital storage oscilloscope, or simply we can call it as DSO. So this is the CRO. The heart of CRO is a cathode ray tube. That is the heart of CRO. So this is what we are going to learn, the working of CRO, not the DSO. This is the DSO. So after learning the CRO, we will learn about DSO also, digital storage oscilloscope. Now for a cathode ray oscilloscope, for this CRO, the heart is known cathode ray tube, that is CRT. CRT is known as the heart of the CRO. CRO is a visual instrument. That means whichever the waveform we want to see, we can see it once you feed the input to the oscilloscope or CRO, we can see the waveform on this green color screen. It comes green as well as blue. We have to understand how this CRO works. These are the different parts of it's a block diagram of a CRO, that is cathode ray oscilloscope. To the input, we are feeding the input signal. That means wherever we have to check the signal, we will apply here to the input. So that input, that is the probe, our CRO probe. The CRO probe is directly connected to the vertical amplifier. So we are applying the input to the vertical amplifier. Vertical amplifier, after the vertical amplifier, there is a delay line. The delay line, through delay line, it is going to the vertical deflection plates. Now, what is the use of this vertical deflection plates? This vertical deflection plates, can you see this blue? This is the electron beam. This is the electron beam. Actually, what we are doing, there is a, now we'll start from the beginning. That is the heater. There is a heater. Just above the heater, cathode is placed. So due to heat, this cathode emit electrons, so that we'll get a beam of electrons. And this beam of electrons pass through control grid. Control grid determines, this simply here mentioned grid, it is a control grid. This grid determines the density of electrons. So by varying the negative bias, we can increase or decrease the density of electrons. These all we will learn in detail in the next video, that is a CRT, cathode ray tube. So this beam, this electron beam is created with the help of, and it is accelerated with the help of some more electrodes, and this beam is going to hit this screen. This screen is the fluorescent screen. It's normally it's a phosphor screen. Now what happens? This electron beams comes and hit on the center of the screen. If you don't apply horizontal sweep and the vertical sweep, we will have a spot here. We will have a spot. I'll draw it and show you how it. See, he will have a spot here. That is the beam. Beam will create a bluish spot on the screen. Now what happens? We have to, if you want to move the spot, if you want vertical movement, that is up and down, then we will apply this through this vertical plates, we will move this beam up and down to draw a waveform or get a image of the input signal. Similarly, and one part of the signal, see here, from here, this point, see one part of the signal is going to the trigger circuit. This trigger circuit is, what is the main function of this trigger circuit is that this trigger circuit synchronizes the vertical section and the horizontal section. That means the horizontal section, there is a sweep generator. This sweep generator helps the sweep generator and the horizontal amplifier helps that means the sweep generator output goes to the horizontal amplifier, and horizontal amplifier controls the horizontal deflection plates. These horizontal deflection plates allow the beam to move right and left. Now we got vertical deflection plate is providing the up-down movement, and horizontal deflection plates are providing the left-right movement. Now this is like a XY graph. We can plot any kind of waveform using this. Now, what is the function of this trigger circuit? The trigger circuit synchronizes the vertical amplifier or vertical section and the horizontal section. That means, see now, to display if you want to capture the waveform exactly as the input, first our sweep generator should start. Sweep generator, also known as time-based generator. This is also known as time-based generator. This will generate sawtooth waves. Time-based generator. So this, to display input waveform properly from the starting without missing any data or information, first the sweep should start, the time-based signal has to be started, then we have to apply the input signal to the vertical deflection plates so that we will get a clear image. And some more things what I have not shown in this diagram is the power supply. It has got a low voltage power supply, usually a low voltage power supply and high voltage power supply. Low voltage and high voltage. High voltage is required for the accelerating anodes and focusing anodes of the CRT. A low voltage, the CRT heater is used as actually low voltage. This low voltage, just 10 volt, this 10 volt DC or AC can be used by the heater. Now we will just get into little more details about it. So here I have mentioned what are the parts of a CRO. The main part is the vertical amplifier. Then we have delay line, trigger circuit, sweep generator or time-based generator, then horizontal amplifier and CRT. Okay, this is the what is definition of cathode ray tube. It's a visual display instrument, and CRO display voltage as a function of time. Because actually what we are having on the display, we are having a display like this or XY. So here the CRO is displaying the voltage as a function of time. So this is also known as a XY plotter. What is the working principle of CRO? In an oscilloscope, the electrons are emitted from the cathode. So the electrons are emitted from the cathode, accelerated to a high velocity using the accelerating anodes and brought to focus on the fluorescent screen. That is our phosphor screen. These rays are also, this beam is also known as cathode rays because it's emitted by cathode. And the screen is the phosphor screen. Generally it is phosphor screen. Phosphor screen. Now we will see what are the blocks of a CRO. Vertical amplifier. This vertical amplifier is the most important block in the CRO. It decides the bandwidth of CRO. See, when you buy a CRO, it will specify 50 megahertz, 100 megahertz, 1 gigahertz. That is decided by the vertical amplifier. Then the vertical amplifier itself decides the gain bandwidth also. So this is the most important block in a CRO. And we can see, so CRO has got two modes, that is a YT mode and XY mode. Normal measurements, in YT mode we will make the normal measurements like voltage, frequency. Once you know the frequency, you can calculate time. Such kind of measurements we make using the YT mode. But when we want to study the phase relation between two signals, we use XY mode. Phase relation and frequency relation. Phase relation, comma, frequency relation. Frequency, a relation of two signals. We use the XY mode. In XY mode, when we use, we will get Lissajous patterns. This also we will learn in different video detail. Lissajous patterns. In the XY mode only we get the Lissajous patterns. Next, what is the use of this delay line? The vertical delay line allows the horizontal sweep to start prior to the vertical deflection. First, the horizontal time base should be generated so that the entire input waveform can be viewed without losing the initial part of the waveform image. So what happens if delay line is not there? Why delay line in the vertical section? Horizontal signal is also called the time-based signal, which deflects the electron beam, is initiated or triggered by the, see, we are taking a fraction of the signal from the vertical section and we are triggering, using the trigger circuit, we are triggering the sweep generator. So if the delay line is not there, we are going to lose the waveform image. Now, let's understand what is a time-based generator. Time-based generator, and one more thing, the vertical amplifier section. What and all is there in the vertical amplifier section? Here, I forgot to tell you. See, simply we can, let us assume that this is the entire vertical amplifier section. Vertical amplifier. So, this input should go to a alternator. Alternator means it will bring down the signal amplitude without affecting the signal shape. Alternator. Then we should have a high impedance FET amplifier. Normally it's a FET amplifier, high impedance. Then we will have a push-pull amplifier. These are the internal block diagram of the vertical amplifier, FET amplifier. Then what we will have? A push-pull amplifier. We will have a push-pull amplifier. Push-pull amplifier. Then we will get the output. And we get the output here. So this output goes to the delay line. Okay, now what about our time-based generator, or as shown in the block diagram, sweep generator? See, the tube generator helps to move the waveform from left to right. So, like this, we have the tube waveform. I'm not drawing it properly. This is sawtooth wave. Okay, this is sawtooth wave. Now, this is what this now. If you see this waveform here to here, this timing. There's a time for this is the increasing time of the sawtooth wave. This is I'll mention it as TS. And see here this time is I have shown little magnified. It is not going to take so much time actually. This is the TR. Actually, what is happening during TS? A beam moves from left to right. Left to right. This is known as the trace time. Trace. This is known as the trace time from left to right. Now, once it goes to right, it should come back immediately to draw the to draw the image again and again. So next TR. So we can mention it as capital R or small r, a small t, it's fine. TR. A beam moves from right to left, and this time is known as the retrace time. Retrace time is known as the retrace time. So now you understood what is trace time and retrace time. So when you apply this kind of ramp signal to the amplified version of this kind of ramp signal to the horizontal deflection plates, it moves the beam from left to right and right to left. Now we have the horizontal amplifier. As I told you, we have two modes in CRO, the YT mode and XY mode. Now in the YT mode, time-based signal is applied to the horizontal section, and the input signal is applied to the vertical section, vertical amplifier, vertical input. But in XY mode, what happens? And external, we will apply one signal to the in the XY mode, we apply one signal to the vertical input and the other signal to the horizontal input. So we have to select the mode, which mode we are. There will be a mode selection button, that is you want XT mode or XY mode. So in the XY mode, horizontal amplifier will be getting a input signal, not the time base. To measure, as I told, to measure the phase and frequency relation between two signals, we will use the XY mode. Now, to measure, let us say, if we want to see a sine wave on the oscilloscope, the wave has to be stable. Correct? It has to stable. By adjusting the horizontal tube, we can get the waveform stable. Trigger circuit. What is the function of trigger circuit? This is used to convert the incoming signal into Ziegler pulses to trigger the time-based generator so that the input signal and tube frequency of the time-based generator can be synchronized. See, the input signal and the time-based generator has to be synchronized. Then only we will get a stable waveform so that we can make the measurements or comparisons, or we can study the designs. Now finally we come to the CRT screen. CRT screen is the CRT screen. See, it should be made of a high persistence material. That means what? Once the electron beams hit the screen, it should illuminate, and that illumination should stay there. Then only our eyes can detect that as a to get the feeling of a continuous waveform. That persistence of the material has to be high. Normally we are using phosphor. And if our horizontal and vertical voltages we are not applying to the deflection plates, then what happens? There will be a center spot on the screen, and there will be something called center burning of the screen. And actually what is happening when it illuminates? We are converting kinetic energy. This kinetic energy of the electrons is converted to light energy. That is what happening on the phosphor screen. I hope now you got basic idea about the CRO working. It is not so complicated. Next we will learn about what is called the CRT. Then by comparing both two, you will understand very easily. So anything should be okay. So we have studied CRO, not the digital storage oscilloscope. In the next video, we will study a CRT. Then we will go to DSO. If you like the video, please share with your friends. Don't forget to hit the like button.